Welcome to Golden Era Construction Managers. Most construction videos show what tools look like. We explain when they are required, how they are used, and what happens when they're used incorrectly. Fall protection is the single most important safety system in construction. Not because it's complicated, but because it's often misunderstood. In this lesson, we're breaking down fall protection systems in detail so you understand not just what to wear, but when protection is required, what type applies, and how systems actually work in real conditions. A fall hazard exists whenever a worker is exposed to a fall to a lower level. That lower level could be the ground, a floor below, equipment, or a structural surface. The height alone does not define the hazard, the exposure does. If a worker can lose balance and there is nothing preventing or stopping the fall, a fall hazard exists. This applies to roof edges, floor openings, scaffold platforms, ladders, and unprotected sides of structures. One of the most common mistakes on job sites is assuming a fall hazard only exists at extreme heights. In reality, many serious injuries occur from relatively low elevations because the worker lands awkwardly or strikes an object on the way down. Fall protection decisions are based on exposure, not confidence, experience, or speed of the task. A worker who has done the same task for years is still exposed if a fall path exists. Exposure means there is a path from the working surface to a lower level without a physical barrier or system stopping the fall. If that path exists, protection is required regardless of how short the task is. This is why just stepping over for a second is one of the most dangerous phrases in construction. Not all falls are the same. Same level falls involve slips or trips where the worker lands on the same surface. Falls to a lower level involve a vertical drop. Fall protection systems are designed primarily for falls to a lower level. However, surfaces that are slippery, unstable, or uneven increase the likelihood of both types. Understanding the difference matters because the protection methods change depending on the type of fall exposure present. Fall protection follows a logical order. First, eliminate the fall hazard if possible. If elimination isn't possible, prevent the fall. If prevention isn't possible, arrest the fall. This distinction matters. Guardrails and covers prevent falls. Harness systems arrest falls after they begin. Preventing a fall is always safer than stopping one mid-air. Guardrails are one of the most effective forms of fall protection because they do not rely on worker action. Once installed correctly, they protect anyone who approaches the edge. A complete guardrail system includes a top rail, a mid-rail, and in some cases a toe board. Each component serves a purpose. Removing one part compromises the entire system. Guardrails must be securely installed and capable of withstanding applied force. Temporary rails made from scrap material often fail because they are not designed for load or impact. Any opening that a person could fall through must be protected. Protection can be achieved using guardrails or covers. Covers must be strong enough to support expected loads and must be secured so they cannot shift. Simply laying plywood over an opening without fastening it is not acceptable. Covers should also be clearly identified so workers know what they are stepping on. Many fall incidents occur when a cover breaks or moves unexpectedly. Safety nets are used when other forms of protection are not feasible. They are typically installed below the working surface to catch a falling worker. Nets must be properly installed, maintained, and positioned close enough to the work area to reduce fall distance. Improperly installed nets provide a false sense of security. Personal fall arrest systems are designed to stop a fall after it begins. These systems do not prevent the fall itself. They reduce injury by limiting the distance and force of the fall. A complete personal fall arrest system includes 3 parts: a full body harness, a connecting device, and a suitable anchor point. All 3 must work together. If any component is missing or incorrectly used, the system fails. Harnesses are designed to distribute fall forces across the body. They must fit properly and be adjusted correctly. Loose straps, twisted webbing, damaged stitching, or missing components make the harness unsafe. Harnesses should never be modified or altered. Wearing a harness incorrectly is equivalent to not wearing one at all. Connecting devices include lanyards and self-retracting lifelines. Each has a specific purpose. Shock-absorbing lanyards reduce the force applied to the body during a fall. Self-retracting lifelines reduce free fall distance and are often used where clearance is limited. Using the wrong connecting device for the situation can result in serious injury even if the system appears complete. Anchor points must be capable of supporting required loads and must be positioned correctly. Not every solid-looking object is an acceptable anchor. Anchors must be designed, rated, or approved for fall protection. Improvised anchors are one of the most common violations on job sites. The direction of force matters. An anchor that works in one direction may fail in another. Fall arrest systems must limit free fall distance and provide sufficient clearance below the worker. Clearance includes the worker's height, the length of the connecting device, the deceleration distance, and a safety margin. Failure to account for clearance can result in the worker striking a lower surface, even though they were tied off. This is one of the most misunderstood aspects of fall protection. Ladders are a leading source of fall injuries. Falls often occur because ladders are used incorrectly rather than because the ladder fails. Common issues include incorrect ladder angle, improper height, failure to secure the ladder, and using ladders for tasks they are not designed to support. A ladder is not a platform and not a scaffold. Treating it as one creates fall exposure. Scaffolds must be fully planked, properly supported, and equipped with guardrails when required. Access points, load limits, and foundation stability are critical. Moving scaffolds without authorization or removing components compromises the entire system. Scaffolds create a working surface, but they also create new fall hazards if not assembled correctly. Roof edges and leading edges are high-risk areas. Protection methods depend on roof slope, surface conditions, and work activity. Weather plays a major role. Wet or windy conditions increase slip risk dramatically and must be accounted for when selecting protection. Fall protection equipment must be inspected before each use. This includes harnesses, lanyards, connectors, and anchors. Signs of damage include frayed webbing, cracked hardware, missing labels, and deformation. Damaged equipment must be removed from service immediately. Improper storage shortens equipment life. Sunlight, moisture, chemicals, and heat degrade materials over time. Equipment should be stored clean, dry, and protected from damage. Many failures occur because equipment was damaged between uses, not during work. The most common fall protection failures include incomplete systems, improper tie-off, bypassing protection for speed, and assuming experience replaces protection. Falls often occur during routine tasks, not complex operations. Familiarity increases risk when it leads to shortcuts. Fall protection is not about equipment alone. It is about understanding exposure, selecting the right system, and using it correctly every time. The safest workers are not the most confident. They are the most disciplined. To continue this construction safety series and build real job-ready knowledge, subscribe to Golden Era Construction Managers.